Well, we've looked at gradients. Now we're going to actually discuss finding equations of lines. So, first thing we need to do is review the three different forms of a line that we're going to use in this exercise. The first one, general form, which we've seen before. And one thing that we haven't discussed before is general form of a line, looking at the gradient. The gradient can be found by using gradient equals minus a over b, where a is the number in front of x and b is the number in front of y. So that'll save us from having to rearrange the equation into the form y equals mx plus b to find the gradient. So remember, gradient is equal to minus the coefficient of x over the coefficient of y. The second form of a line that we're going to deal with is going to be the gradient y-intercept form, which we have seen before, y equals mx plus b, where m's the gradient and b is the y-intercept. And the last one, you haven't seen this one before, and it's not used very often, and to be honest, you can get by without it, but it's x on a plus y on b equals 1, where a is the x-intercept and b is the y-intercept. So again, you don't really need to memorize that one. You can actually use the other forms if you want, but that's nice and fast on occasions if you have the x and y-intercept. Now, we need to be able to find the equation of a line. We've got three formulas that we're going to use in this exercise. The first one we've seen before, y equals mx plus b. The second one, we've used this before as well, y minus y1 equals m, x take x1. The top formula, y equals mx plus b, you use when you've been given the gradient and the y-intercept. The second one, you use when you've been given the gradient and any point on the line. You just need to know one point on the line. It doesn't matter where it's situated. And the final rule is really the same as the point gradient form, except instead of writing m, what you'll notice is that we've got the gradient written down. So we've actually got y2 take y1 over x2 take x1 written just here, which is another way of writing the gradient. So it's basically the same rule. Let's try some examples. So find the equation of a straight line with a gradient minus 5 that passes through negative 2, 5. Which of those three rules are we going to use? Well, we know the gradient and we know a point. So effectively we know the gradient equals minus 5, and from that point we know x1 equals negative 2 and we know y1 equals 5. So that's the information we've got, which means we can use the formula y take y1 equals m, x take x1. We'll end up with y take away y1, which is 5, equals gradient minus 5 x minus 2. So you get y take 5 equals, let's expand this out, that will give me minus 5x. Minus 5 times a positive 2 will give me a negative 10, and I missed the x there. Now, so that our answers correspond with the answers in the back of the book, we'll put the final solution in general form. So we'll get everything on the left hand side. On the right hand side it'll say equals 0. So the first thing we're going to do is we're going to look at the question and we are going to add 5x to both sides. And we'll also plus 10 to both sides. And by doing that, we'll make sure that our equation is balanced, and we'll end up with 5x plus y minus 5 plus 10 gives plus 5 equals 0, and that is the equation of the line in general form. Second example, find the equation of the line passing through those 2 points. Well, those 2 points, when we look at the 2 points, that means effectively we've now got an x1 and y1 and an x2 and y2, because that's my first and second point. So what formula will I use? Well, if we've been given 2 points, let's go back. What have I done here? I've pushed the wrong button. There we go. We need to be in example 2. If we've got 2 points, we need to use the formula y take y1 equals y2 take y1 and x2 take x1, x take x1. Let's try using it. We end up with y minus. Now the y value of the first point is minus 2. So it's y minus minus 2, which is y plus 2. The y value of the second point is 5 minus the y value of the first point we've already said was minus 2. 5 minus minus 2 is 5 plus 2. x2 take x1. x2 take x1. 8 take 3. x minus x1 was 3. Let's tidy this up a bit. Y plus 2 equals 7 over 5. X minus 3. Now we've got a fraction here, and I'm going to get rid of the fraction. Don't like having fractions, so in order to get rid of the fraction, I'm going to times both sides by 5. If I times this side by 5, they cancel each other out, times the left hand side by 5, and I end up with that bracket, which means I can expand the bracket out now, and I'll get 5y plus 10 equals. Now on the left of the bracket I've only got the number 7, so let's expand that. 7x minus 21. And effectively now I want to leave the answer again in general form, so I will minus 7x and plus 21 to both sides. And by doing that I'm going to end up with the answer of minus 7x plus 5y, 10 and 21 make 31, equals 0, and there's the equation of my line in general form. And our final example, find the equation of the line with x-intercept 4 and y-intercept 3. Well, this is one of these rare ones. I could actually treat the x-intercept as the point 4, 0, and the y-intercept as the point 0, 3, and then use my 2-point formula. But I'm going to use the shortcut formula, which, as I said before, you don't really need to use, but we're going to. And it goes like this: x over a plus y over b equals 1. Now if we use the shortcut formula, a is the x-intercept, b is the y-intercept, so we get x over 4 plus y over 3 equals 1. If I want to leave the answer in general form, the quickest way is to multiply both sides by 12, because 4 and 3 are the denominators, they're both going to 12, and we'll be able to multiply that out and get our answer. Let's see what we come up with. 12x on 4 becomes 3x plus 4y equals 12, and 3x plus 4y minus 12 equals 0. That's our answer in general form. Done. Time for you to do some questions. Have fun.